Hello students, in our previous video, we derived a formula called distance formula. As we know, this formula is used to calculate or find the distance between two given points in a coordinate plane. Accordingly, if 2 points A and B are given, distance AB between them can be calculated by formula AB is equal to under root x2 minus x1 whole square plus y2 minus y1 whole square, where x1 is abscissa of A and x2 is abscissa of B, and y1 is ordinate of A and y2 is ordinate of B. x2 minus x1 is difference of x coordinates and y2 minus y1 is difference of y coordinates. Do you know students, distance formula finds many applications in our daily life as well as in physics, engineering and seismology, etc. Distance formula has many applications in our everyday life, like mapping distances between two places or for navigation like GPS, etc. For example, to estimate the distance between two places, we just have to get the coordinates of those places from map and calculate the distance using distance formula. Apart from this, it can also be used to find out or prove that given figure is square, rhombus, rectangle or triangle, etc. We can also use distance formula to find out whether given points are collinear or not, or to find out the areas of given figures. Let us see each application one by one. First, let's see how we find distance between given points using distance formula. Students, suppose we are given 2 points in a given plane. Say, point A and B are at some distance. To find how far they are, we can directly use the distance formula. But suppose we are given one more point, say P, which is equidistance from point A and B. Students, do you know what equidistance means? I am sure you know it. When any point is at same or equal distance from certain points, it is said to be equidistant. Here, point P is at equal distance from A and B both. So we can say that distance PA is equal to distance PB. Students, note that it is not necessary that always P is at equal distance. That is, it is equidistant. Sometimes it can be near to A. In this case, PA is smaller than PB. And sometimes it can be near to B. In this case, PA is greater than PB. Now students, is point P in line with A and B? As you can observe that it is not in same line. But if we shift P on the line segment AB, then yes, now as you can observe that point P is on one line with A and B, but P is still at equal distance from A and B. That is, still PA is equal to PB. But here P will become midpoint of AB. That is, P is exactly in middle of AB. Now, if we shift P towards A or B, its distance will change. And we will say that P is not equidistant from A and B. Students, can you guess geometrically what is this condition called as? And how can we symbolize them? Yes, you are right. You already know that this condition is known as collinearity of points. As you know, word itself consists of co, which means to coexist, and linear, meaning one line. Thus, collinear points means all the points that are present in one line. Say for example, in our previous case, where P was in between A and B, it can be represented as A-P-B. But students, let me give you a task. If I ask you to prove that these points are collinear, how will you prove it? It is very simple, students. Recall, you have already proved this important condition of collinearity. According to it, sum of all small distances between collinear points is equal to the total distance. Therefore, here in our case, we can say that if A-P-B is collinearity, then AP plus PB is equal to AB. That is, distance AP plus distance PB is equal to distance AB. Student, for any given points, if this condition is satisfied, then we can say that given points are in one line or collinear. Now, let us understand all concepts better by examples in our next video.